Hello everyone. What I'd like to do in this video is show you how to use your calculator to evaluate logarithms. So in nice situations, we can evaluate logarithms. So the numbers have to work out pretty nicely though. Like for example, if we wanted to evaluate log base 4 of 16, for example, well, what is this asking? This is saying, well, 4 to what power gives you 16? Basically, I just switched forms. This is saying 4 to the power of x equals 16, and I want to know what the value of x is. Well, you can use the drop the base method, or we can just think about it. I hope you believe that 4 squared equals 16. So log base 4 of 16 is equal to 2. Why? Because 4 squared is 16. So this is something easy to calculate, which is nice. Also, in the last video, we did an example where we had two logarithms separately were tough to calculate, but when we kind of glued them together nicely, we were able to do it by hand. Let's see, what was that? We had, in the last video, it was 2 videos ago, I don't remember. Log base 3 of 6 minus log base 3 of 2. Okay, well, separately, these are tough to calculate. So, for example, log base 3 of 6, what is that? I don't know. This is saying 3 to what power gives you 6? I don't know. Well, I at least know that 3 to the first power is 3, and 3 squared is 9. So, all we know, I guess all this is telling us is that log base 3 of 6, well, it's something between 1 and 2. Log base 3 of 6 is some number between 1 and 2. What is it? I don't know. It's not a very nice number. And similarly over here, this is asking 3 to what power gives us 2. Well, we know that 3 to the 0 is 1, and 3 to the first power, what is 3? So I guess all we know here is that log base 3 of 2 is somewhere between 0 and 1. What is it? I don't know. It's not a very nice number. But it just turned out with log rules, though, with log rules, this was easy to do because since we have the same base and we're subtracting log rule, what was it, 2? Log rule 2 says that this is the same thing as log base 3 of 6 over 2, or this is log base 3 of 3, and this is asking 3 to what power gives you 3? Well, I hope you believe that 3 to the first power gives you 3. So the answer here is 1. So I at least know that these two things have to sum to 1. But what's interesting is separately these are tough, but when I subtract them, it's easy. Okay, well, how do I figure out exactly what this value is and this value is? Okay, how do we figure that out? Well, we'll use a calculator. But there's even some problems with our calculator. Well, not necessarily there's a problem. It's just how they're programmed. Notice on our calculator that we only have 2 log buttons. Now, I don't know, maybe your calculators are more fancier than mine, but on most calculators that I've seen, you will only have a log button and a natural log button. So sure, we can calculate logarithms that have a base of 10. So for example, like if we wanted to figure out what log of 20 is, for example, so notice since I didn't write any base here, this is known to be base 10. Well, while I could use a calculator, I think it's kind of fun maybe to find a bound on this. So what is this saying? This is saying 10 to what power? 10 to what power gives you 20? Well, let's see. Well, 10 to the first is 10, and 10 squared is 100. So whatever this is right here, whatever log base 10 of 20 is, at least we know it's between 1 and 2. It's between 1 and 2. Okay. Now I would guess that it's probably, it's probably going to be closer to 1 than 2 because 10 is closer to 20 than 100. So I'm going to guess it's going to be closer to 1. Okay, well, what is it? Let's use our calculator. So we can just push our log button. So if we push log, and put a 20 and hit enter, well, this is 1.3. How about around 4 decimal places? 3, 0, 1, 0, 2, so I would leave this as a 0. So I'll put a roughly. Okay, so this is saying that if you take 10 and raise it to the roughly the 1.3010, I'm rounding, so we should get close to 23 or 10 to the power of 1.301. I mean, this is saying 19.9986, which is close to 20. But if you took 10 and raise it to exactly the log of 20, these are inverse functions, they cancel each other out, and we should just get out 20. You can even check that with your calculator. Push 10, and then due to the power, push log 20, close that parenthesis, it's going to spit out 20. Cool. Okay, well, sure, we can do this with log base 10. Okay. We could also do it with e because, well, our calculator's got a natural log button. So if we wanted to figure out, what's the natural log of 2, this number will pop up in calculus. What is this saying? This is saying e to what power gives you 2? Well, again, we could say, well, e to the 0th power we know is 1, and e to the first power, remember what e is. E is that number, it's roughly, 2.718? So at least we know that the natural log of 2 is somewhere between 0 and 1. Okay, I'm going to guess that it's probably going to be closer to 1 because 2.718 is closer to 2 than 1 is. So I'm going to guess it's going to be closer to 1. Well, we don't really have to find a bound on this. We can figure out exactly what it is. Let's go ahead and push our natural log button. So natural log of 2. So we have the natural log button. We have the natural log of 2. You don't have to close those parentheses on there. I'll kind of show you. But like I've said, I'm super paranoid about parentheses. So I don't know. I'm always going to put parentheses. You'll get the same answer. So here we get the natural log of 2. The natural log of 2 is roughly 0.69. So I guess I was right to think that the natural log of 2 would be closer to 1 than it was 0, because again, 2.718 is closer to 2 than 1 is. Okay, this still isn't helping us, though, when we're trying to figure out what log base 3 of 6 is or log base 3 of 2 is. Well, there's no log base 3 button on my calculator. Maybe on yours, but not on mine, and not on a lot of calculators. Okay, why? Because there's the change of base formula. There's a formula that allows us to change from one logarithmic base to another logarithmic base. Okay, I'm going to show you what the formula is, then I'm going to prove it to you. It's a quick argument. It's really a direct consequence of log rule 3. But the change of base formula can help us calculate log base 3, log base 7, any log that's not 10 or e on our calculator. The change of base formula. Okay, this is what it says. It says that log base b of x is equivalent to, now you can change this to any base you like, I'm just going to call it a. So we could change this to log base a, and the formula would be, this is the same thing as log base a of x all over log base a of b, where a is the base I'm choosing to use here. Now, a way that I remember how to kind of organize this, well, the log has to be the new base that you could choose, and you could choose any base that you would like. Well, how do I know that the x goes in the top and the b goes in the bottom? For me, at least, when I look at this expression, notice that this x looks like it's a little bit higher than the b. So it's log base a, whatever you choose it to be, of x over log base a of b. So that's the way I remember it. The x is higher than the b. The x is higher than the b. That's the way I remember this formula. So let's use it, and I'll show you as an example. So in this situation, let's say we're trying to figure out what log base 3 of 6 is. So since we only have a base 10 and a base e in our calculator, well, it doesn't matter which one we use. So log base 3 of 10, well, we could change this. log base 3 of 6. Let's change this to base 10. So this would be equivalent to log of 6 over log of 3. And now we can plug this into our calculator. So let's figure this out. So log of 6, close that parenthesis, and divided by log of 3, close that parenthesis. So this is what I've typed in my calculator. Hit enter. Well, this is saying that this is 1.6309299754. Well, cool. So I guess if we're thinking if we're thinking it's this minus this has to be equal to 1, you can probably guess what log base 3 of 2 is. Log base 3 of 2 is probably 0.6309299754. Before we do that, we'll do it in just a second, but we didn't have to use the log button. We could use natural log button. Let's test it out. Log base 3 of 6 should be equivalent to, if we change it to base e, natural log of 6 over the natural log of 3. Okay, let's test it. Natural log of 6 divided by the natural log of 3. Okay, whoa, yes, 1.630929754. It's the same. Math works, it's great. Okay, so that's how you can use your calculator, by using this thing called the change of base formula. Okay, so I guess while we're at it, let's verify if we want to figure out, what is log base 3 of 2? Well, this should be, I guess I already have logs up here, so you could use natural log or log. Normally I use natural log, it's like one less letter, but I've already started. So log of 2 over log of 3. This better be 0.6309 if this up here is correct. Okay, so log of 2 divided by log of 3. Oh yeah. 0.6909297536. How cool is that? Okay, how cool is that? Here my calculator just went out to one extra decimal place because this is rounding. But yeah, this is great. It's working. Beautiful. This is great. All right, so now the question is why is it true? Why is this true? Why is the change of base formula true? It's just a direct consequence of, log rule 3. Okay, well, let me show you what I mean. So log rule 3 says the following. This is just log rule 3 I'm going to write up. Log rule 3. It says what? It says that if you have log of any base b of n to the m, well, you can bring the m out front. M times log base b of n. That's what log rule 3 says. So let me kind of show you how you could have just used this, maybe even without memorizing the change of base formula. For example, we were trying to figure out log base 3 of 6. Okay, we're trying to figure out what value this is. So this is equal to x. So what we could do here, without using the change of base formula, basically what I'm going to do here is how we derive the change of base formula, is you could say, well, what's this in exponential form? You could say, well, this is 3 to the x is equal to 6. And then what we could do is we could take either log of both sides or natural log of both sides. Let's take natural log of both sides. You could take log of both sides. If we take natural log of both sides, well, what happens? Log rule 3 says I can bring this x out front. So this is equivalent to x times the natural log of 3 is equal to the natural log of 6. So this says, if I divide both sides by the natural log of 3, that x is equivalent to the natural log of 6 over the natural log of 3. So match your x's the same thing as the natural log of 6 over the natural log of 3. This is the change of base formula. You could have done the same thing. Log rule 3 works with any base. So you could do log, and I'm just writing an extra letter. Put a log here, put a log here, and then these would switch to logs. These would switch to logs. So all of these are equivalent. And that's how we calculated what log base 3 of 6 was. Cool. Okay, let's just do it in general. Let's just do this in general. Okay. I mean, this is like if you forget the change of base formula and you want to evaluate this, you could just say, oh, put it in exponential form, take log, base 10 or natural log of both sides. You hopefully remember log rule 3. Don't forget it. And you could piece it all together yourself. So that's a way for, if you don't want to memorize the change of base formula, just switching to exponential form and using log rule 3. But that's essentially how we prove. That's how we prove the change of base formula. So let's say we have log base b of x. We're just going to show it in general. Okay, let's say that this is equal to some value. We'll call it y. Okay, well, if I want to change this into exponential form, this says that b to the y is equal to x. So now how about we take log base a of both sides? Log base a of both sides. Okay, well, log rule 3 lets me move that y out front. So this is rule 3. So y times the log base a of b is equal to log base a of x. Divide both sides by log base a. We have y is equal to log base a of x all over log base a of b. Match everything up here. So this is equivalent to log base a of x all over log base a of b. And there we have it, the change of base formula. It's a really nice, useful tool if your calculator doesn't have logs of different bases in it. So hopefully what I also hope to show you here is that you can memorize the change of base formula if you'd like, or you can just say, hey, I know how to have something in log form, switch it into exponential form, take whatever flavor of log you want of both sides, use log rule 3, bam, you'll get to the same answer. So that's all I have for this video here. I hope you enjoyed it. We'll see you in the next one where we start solving logarithmic equations and exponential equations. We'll see you there. Take care.